Sorry, as Russell was saying, the topic today is with regards to batteries, right? I have prepared this presentation. Battery-based focus is on this particular product, which is meant to be for residential and commercial applications. The product is called Ingeteam Sun Storage, and it's a one play because it's like the small version that we have for such a type of systems, you know, like residential small applications. All the points that I will be talking about. I have to mention that I have included one point here that I'm not going to cover today, which is sizing. Okay, I thought it was relevant to include this in the presentation so you can, you know, check it in the future whenever you need it. But because this is going to be like a short presentation, I don't want to spend too long in this point. But I want you to have that information in case you need it. Who we are and what we do. Ingeteam is a company that was created 30 years ago here in Spain, and after a while we started spreading around the world. Now we are a worldwide based company. We have offices all around the world, States, Mexico, Brazil, Chile, and South Africa. We also have an important office over there. In Europe we have quite a few, because that was at the beginning was our first. We started in Spain, but we started then spreading to Italy, France, Germany, the UK, and so on. Then we also have offices in Australia, India, and China, and some offices, sales offices in these countries here that are painted in blue. Within Ingeteam, we find 4 different departments, let's call it that way: energy, industry, marine, and wind power, solar power, hydropower, things like that. Obviously, we are part of the solar department within energy. And in the next slide, I'm showing some data relevant. I mean, some data that is with regards to the solar department. We've been working in the field for more than 13 years, around 4 gigawatts produced worldwide. This is the amount of inverters we have been producing in the last few years. And well, this is the number for the company so far, and well, some other marketing data that might be interesting for you. So as you can see, we're a worldwide company. We have offices everywhere and systems installed in pretty much in every country in the world. Okay, so let's now focus on the topic that I want to cover today, which is battery-based systems using Ingeteam Sun Storage One Play. Obviously, I'm going to talk about, you know, how we can include batteries within our systems in order to improve the way they work. There are several ways to do it. I'm going to try to explain all the different, you know, systems we can find and how we can actually use our inverter Ingeteam Sun Storage One Play to work in all these different modes. Okay. So this is this picture here that I'm showing is the one. I mean, this is the product that I'm going to be talking about in the Ingeteam Sun Storage One Play. The one you see in the image is the inverter without transformer. This is a TL version. We also have the T version, the inverter with transformer. The inverter with transformer is normally used in 3-phase systems, because with this particular inverter you can actually build 3-phase systems by implementing or by installing one of these units in every one of the 3 phases. And then basically you take cables from one inverter to the other, and by doing that you synchronize them, and they work in a way that it produces a 3-phase grid. Okay, so in those 3-phase systems we normally use inverters with transformer. We also use inverters with transformers in those single-phase systems where we are required to ground one of the inputs. Okay, sometimes, you know, depending on the type of PV modules you use, sometimes you are asked to ground either the positive or the negative input. If you have to do it that way, if you use, you know, for example, thin film technology, then you will be asked to ground the positive, for example, or the negative. In those particular cases, you are asked or you are required to use the inverter with transformer. Okay, that's another scenario where we use the inverters with transformer. Or sometimes, for example, the batteries, there might be battery producers that ask you to ground either the positive or the negative pole, the positive or negative input, and then when you have to do it that way, then you are required to use the inverter with transformer. Okay. So far, we have inverters that range, well, we have two different units for residential application. One ranges from, one goes up to 3 kilowatts. The other version goes up to 6 kilowatts, okay? Well, this is a single-phase inverter, as I said before, with PV input. So here, we will plug not only the batteries, but there's also a PV input where you can connect, well, you see in this graph, if you have the batteries connected, you can also connect modules to it, okay? PV modules in one single unit, okay? So this makes the whole thing, I mean, the installation will be easier because you have everything in one single unit, and obviously you reduce cost, and this so far has been proved to be a very robust inverter, okay? In addition to these two renewable sources, let's call them renewable, even though this might not be renewable at all, but, well, it can work as a renewable source because you can blackouts quite frequently or very long blackouts throughout the day. In those scenarios where you have the grid but it's not very stable, you can always use this inverter, and when you have those, those disconnections, you can always connect the batteries to fit your loads. So the loads don't notice that there's no grid at that particular moment because your inverter is producing the grid itself. This, here, as you can see, these are the characteristics. I'm not going to really enter much into this because this is all included in the data sheet from the inverter. This is very much the characteristics of a PV array you can connect to your inverter. You can go up to 11.5 kilowatts peak. You are able to absorb or to take up to 30 amps from the PV modules. For batteries, these are the conditions, the voltage that we require from the batteries ranges from 40 to 450 volts. We're able to take up to 50 amps in both directions, okay? We're able to take 50 amps from the batteries towards the inverter or the other way around. And the type of batteries we accept are these ones: lead acid, nickel cadmium, or lithium ion, okay? And these are the characteristics for the genset, okay? So this is pretty much, this drawing shows more or less the elements you can connect to your inverter. Later on, I will show a picture where some of these elements are connected, and you can get to see, how the connections are made. This inverter can work in two different ways, okay? It can work as a standalone unit, producing an AC grid here, and a 230 volts, 50 or 60 hertz grid to which we will connect our loads, okay? This is, well, when you work as a standalone element, this is what we call a voltage source because it produces voltage and frequency, okay? And then your loads will consume power from that grid that is actually produced from these sources here. The other way that this inverter has to work is as a current source, meaning when you have a grid that is produced either by the genset or by the public grid, by the utility, this inverter could inject current to that grid. So in this, you can follow the indications given in this image here, okay? In that particular case, this inverter will be working as a grid source, so this will produce the grid, well, most of the time. I mean, let me rephrase. Let me explain that better. When you work with batteries or modules, then you create the grid. You create a grid with a frequency and a voltage to which we connect the loads. when the genset is the one that is, when the genset is activated, he is the one that produces the grid. So the grid then is the frequency and the voltage from that grid is imposed by the genset itself. And here, basically, what we will have is frequency and voltage produced from either the genset or the renewable sources. Okay, but here we will have an AC grid, a single-phase AC grid. Okay, we can connect another type of inverters, such as this one. This is an Ingeteam one-play. This is a current source. This is an inverter that is an on-grid system, an on inverter that feeds current to that particular grid. Okay, if we use this approach, then we are able to increase the amount of PV power that we have installed in our system. And not only that, another positive thing is that we don't need cables from this inverter to this one to actually control it, okay? We don't do it that way. We use what we call the AC link concept. So basically, by modifying the frequency from this grid, we are able to control how much power this one is producing, okay? Imagine, for example, that you don't want to I don't know, you want to reduce for any reason the amount of power you are producing from this side. Okay, imagine that you don't want to produce that much. In that particular case, what we will do is to increase a little bit the frequency here, and this will reduce the amount of power that is feeding into that particular grid. So basically, this is a system without communication that is completely controlled by this unit here. Okay. Well, this is something I mentioned before. If I use inverter with transformer, we can actually implement a three-phase system to which we will connect either single-phase loads or three-phase loads. Okay, and this is this image here illustrates very well how the system is actually built. Okay, we have one single genset, three-phase genset. We have one single battery bench for the three inverters. We don't have three battery benches. We have one single unit or one single battery bench for the three of them. And then we also have, three MPPTs. I mean, we will have three PV arrays, or each one of these inverters will have several modules connected to it. Okay, so this is how we will build a three-phase system using single-phase battery inverters, Ingeteam and storage one play. Okay, so now I'm going to enter to the different working modes. You know, all the different things that you can do with this inverter. You know, I mentioned before that there are, depending on the conditions or depending on the client needs, there are different things we can do. Okay, and here I'm listing, or I'm breaking down the four most important things we can do with this inverter. We can build up a standalone system, a backup system, a self-consumption system, or a grid support system. Let me explain each one of them, and I'm going to try to show you, you know, some graphs about how the installation is made. And I want to go through each one of them so you get an idea of what type of things you can do with this inverter. I'm going to start with the first one, the standalone system. I have this image. Well, let me tell you before I carry on that after the training session, I will pass the presentation to Russell. So if you guys need a presentation, or you can keep a copy of the presentation, you can drop him an email, and he'll send the presentation to you. Or if you want, you can also contact me through my email or through ingeteamtraining.com, and there I will send you the presentation so you can use it. Okay. The first type of systems I'm going to talk about are standalone systems. Standalone systems are basically systems that are off-grid systems. You know, there might be many reasons. Imagine that, for example, the place is too far away from the grid. You know, taking the power from the grid to that particular location is too expensive. So you decide to build a standalone system that is disconnected from the grid. Okay, those particular systems normally they have a genset. Okay, they have a backup genset. You cannot rely only on batteries and PV modules because what happens if it's not very sunny, or you have several cloudy days in a row. Then in that particular case you won't be able to charge the batteries, and so it's better to have, just in case, a backup system or a genset that is used as a backup unit for those scenarios or those time periods where you don't have enough renewable power, right? So, but that's optional, okay? That's not compulsory. Okay, you could have a system without. You can take the risk and have a system without the genset. But normally the ones we find are with gensets. The idea is that in this type of systems, when there's PV power, this power is used to feed the loads, and if there's enough, we will feed the batteries. Okay, we will charge the batteries. When the batteries are fully charged, if there's enough solar power, PV power, then what we will do is to reduce, or we will control the amount of PV power that is being produced, okay? But normally, imagine that the batteries are not fully charged, then we will take all the PV power and we will charge the batteries, and at the same time we will feed the loads. When PV power drops down and it's not enough for loads, the loads don't take, they need more power than what it is actually available from PV, then what we will need to do is to use the batteries to provide the rest. The remaining energy needed will be taken from the batteries. Okay, so for those scenarios where the PV power is not enough to actually the loads require more than what is there available from the PV, then we will take it from the batteries. The batteries then will start discharging, and then once you reach a certain value, what you will do is to activate the genset. Okay, and the genset will actually feed the loads and charge your batteries until you reach a certain level. Okay, that level can be configured. Okay, it's what we call short grid here. Before I carry on, let me tell you that all these points, you see here, I have drawn a battery with several lines, and here we have shock max, shock grid, shock min, shock rex, shock desks. All these parameters can be configured by the user. Okay, you go to the inverter display and you can configure all these different state of charge from the battery. You can set this up, for example, to 100%, this one to 70, 60, 50, 40. Okay, it all depends on the type of batteries you use. Okay, but this can be modified by the clients. Okay, so let me show you this drawing, because I think it explains very well how the inverter works. Okay, in this range here, the battery can be charged from PV or from DSL or from PV and DSL, okay? When you reach this point, the battery can only be charged from PV, okay? And when you reach this point, the batteries can no longer be charged, okay? There's people, something not very common. Normally people charge batteries up to 100%, but there's people who want to keep it up to 95%. Okay, you can configure that. So basically, how does this work? How does this strategy work? Basically, you discharge the batteries. Imagine they are consuming power from the batteries. When you reach this point, this value that's been configured previously by yourself, then the inverter will send a command to your genset, and it will turn it on. Okay, it will activate the genset. Then the battery will start charging till you reach this point here. Okay, then you send a command to disconnect the genset. When you reach this point, you could go either down again towards this point here, or you can even go towards the top. If there's enough PV power, you will carry on charging the batteries from this point on. If there's not enough power, PV power, then, and the loads are requesting power, then you probably have to extract more power from the batteries till you reach this point. Once you reach this point, then you send the command to the genset again. You turn it on and you go up to this point and then off and on and on. You know what I mean? You have this hysteresis. But basically when you connect the genset, you don't want to charge your batteries all the way to the top, right? Because what happens if you fully charge those batteries with genset power, you're consuming diesel there, you're spending money. Imagine that then, you charge them all at the 100%, you reach the maximum state of charge, and what if the sun starts shining? You have wasted money. So that's why we give we give clients the opportunity or the chance to actually set this value to whatever they want. I mean that you decide to charge them up to 70% with power from the genset, and then on you charge them with power from PV. Okay, that's how it works in a normal basis. But sometimes imagine that your genset is not available or is damaged or there's a problem with it. Then you could actually take some extra power from the batteries down to this point, okay? The batteries, imagine the inverter sends the command to the inverter to start working, but it doesn't work. Then the batteries do carry on working. You can extract more power from the batteries until you reach this point. At this point, you consider that your batteries are dead, okay? They're fully discharged. So at this point, basically, you disconnect your system. Your loads won't be able to take any power. Why? Because you don't have PV. You don't have, or with the PV you have is not enough to feed the loads. In addition to that, the batteries are fully discharged and there is. So basically, this is it's a bit different to the previous case, because in the previous case, the batteries was actually working actively. Okay, it was, we saw that the battery was discharging and charging quite frequently. In this second type of systems, that's not the case, right? Sorry, oops, I was hearing one noise, sorry. In this type of systems, what we want to do is to keep the batteries fully charged to the maximum point as much as we can. So when the blackout comes, or when the outage comes, the grid outage comes, when there's a grid drop, then we have enough power in the battery to actually feed our loads, okay? So as you can see, the strategy is different. Basically, you keep your batteries fully charged, and when the grid drops, then they start discharging, and they drop down to this value here. So basically, when you size your system, you have to make sure that the size of your batteries is enough to actually feed the loads for the period of time required. Okay, you need to know how much your loads are, or how long the grid drop is going to be, or the grid blackout is going to last. So you size your batteries in taking those values into consideration. So once again, all these parameters have to be configured at the inverter through the display. So this is how it works, okay? Basically, your batteries will start working when the grid disappears, and then they will reach whatever point. And once you reach that point, you will start charging them again till you reach the maximum value. In order to reach that value, from here to here, in this range, you can take power from the grid or from a diesel genset. Sorry, this is not correct. This should be the grid, not diesel genset, because this is actually connected to the grid. And from this point on, you have to charge the batteries taking power from the PV only. Okay? So this is how it works. One of the positive things you have here is that the PV power is used to feed the loads and to charge the batteries, right? But once the batteries are fully charged, once you reach this maximum state of charge, then that PV power is no longer used to charge the batteries, it's used to reduce your consumption, okay? That power goes to your loads, so the amount of energy you take from the grid is less, is limited, okay? So it helps you to reduce your energy bill, okay? That's very positive. The other thing you can do is, if you have too much PV power, and imagine that you have charged your batteries fully. You have reached the maximum state of charge, and you are consuming that power from PV because you have too much. Imagine that you have even more than what you need. In that case, there's two things you can do. You can limit your inverter not to produce that much, or you can even feed the grid. Okay, there are locations where that's all right. Okay, there are countries where feeding the grid is accepted. It's not the case for Spain, for example. I don't know how it is in South Africa, but you could either limit your inverter or you can allow grid injection. Okay. And this is how the system works, okay, very much. So when you reach this point, you disconnect the system, and once the grid is available, then loads will start consuming power from the grid, and you will actually also charge your batteries till you reach this value here, and then from there on, you will charge them with PV. For this type of systems, we have a similar layout. I think you have a blackout and grid power is restored. I have a question. Let me read it and then I'll go. Okay, let me see. Hi, will there be a break in supply when the grid fails? If so, how long? Thank you. If there won't be I mean, it's like a UPS, okay? There won't be a break in the supply. Okay, the length of the break will be 20 milliseconds. Okay, so basically loads won't notice. They won't disconnect. Maybe in the lights, you know how sometimes you see like the light stops lighting for a short period of time, but the loads won't disconnect. It's a 20 millisecond drop, okay, or a 20 millisecond break. So it's not a long one. If you have a blackout and grid power is restored, are you first gonna feed the battery and load, or can you set the battery on the charge from PV? If there's a blackout and grid power is restored, you'll do both things at the same time to actually feed the loads and feed the battery. Okay. Or can you set the battery only to charge from PV? You could do that as well. How do you do it? I mean, if you want your battery to charge only from PV, you will need to play with these parameters here. Okay, the circuit should be dropped down to whatever value you want. If you wanna, you see, from circuit up to the top, the battery is charged using only PV. So you could actually set this up to be over here instead. Okay. So that's, I mean, we give clients the option to do whatever they want by selecting these parameters in the display themselves. In this system, as you can see, it's very similar to the previous case. We have the grid, we have optional PV in case you want. Some people don't want the PV power; they just want to have the batteries, and they want to use the system as a UPS. The system is very similar. You have the bypass contactor. But in this case, we need one extra element, which is this neutral to ground contactor, okay, which is actually controlled by the inverter. Why do we need this neutral to ground contactor? Because when there's a blackout in the grid, then we have to actually produce the grid ourselves using the inverter, right? And the neutral is then activated. This neutral is then activated. So basically, when this works as a voltage source, when this produces the grid from batteries, we need to activate this contactor so the neutral from the system is grounded. Before then, when the power is taken from the grid, the neutral is actually taken from the grid. Okay? It's only when you work as a standalone system, when you produce the grid yourself, when you actually activate this contactor. A second difference is this other line that I have drawn here. This is also optional. This is from non-critical loads. In systems like this, sometimes people want to connect things in a way such that if there's a blackout, some specific loads stop working. For example, the aircon. Okay, imagine that you have aircon in your office, and you know when there's a blackout in the grid, you don't mind the aircon to stop working as long as the rest of the things keep working, right? Imagine that you have a fridge, I don't know, whatever element. Those critical things will be connected here. The non-critical things, those that you don't mind to get disconnected, will be connected here. So when the grid disappears, this will stop working, and the rest will be fed from batteries, okay, from here. Well, from batteries or the optional PV power, okay? Same thing for three-phase systems, okay? Same scenario. Okay, once again, they share, the three inverters share a unique battery bench. And in case of needing to, once again, in case of needing to actually monitor the system, you'll need the Ingeteam EMS board. Let's go to the next strategy, or to the next working mode, self-consumption. Okay, this is very popular here in Europe, I think in your country as well. The way it works is very similar, okay? The priority is to use the PV power to feed loads and charge the batteries. When PV power is not enough for loads, batteries will provide the rest. And when PV power plus battery power is not enough for loads, the grid will provide the rest. So basically, this is a strategy that we use to reduce the energy bill, okay? We'll use solar, battery power, solar power, battery power, as much as we can to reduce the amount of power we take from the grid, okay? When you reach this value here, this shock mean, then the batteries will start charging again, okay? So this is very similar to, remember when I was explaining the standalone, this once again, it can be configured by yourself. You start at whatever point here, you start discharging the batteries because you don't have enough PV, for example. Once you reach here, then we don't take any more power from the batteries, and then we will charge the batteries from the grid until we reach this other point here. This can be configured, it can be downwards here or upwards here. You know what I mean? And it works very similar to standalone, but instead of having the diesel genset, you have the grid, okay? What happened? Well, there's one optional thing. I have drawn it in this gray box, which is you could have, if you want, the standalone capability activated in your system. Why is it needed? Okay, there are certain, I mean, here, for example, in Europe, where the grid is stable, or for example, in your country, where, if you're in a big city where the grid is stable, I mean, you know that the grid is going to be always available, so you don't have to worry about this standalone capability, okay? Basically, your batteries will be always working between this value and this value here, okay? But in case you want the system to be able to keep working when there's a blackout in the grid, then you could actually implement this second part of the strategy, right? Meaning you can actually go beyond this point till you reach this system disconnection point, and you will reconnect the system at this other point when the grid is available, okay? So, well, I think in the next drawing it shows in a better way how to actually implement this standalone capability. Basically, what you're doing is, if the grid disappears, you work as a standalone system, you work as a voltage source, and you feed loads with power that comes from the batteries, okay? But that's something that, at least here in Europe, it's not very common because, like the grid is always there. So whenever you reach this point, you charge again to this second point, and that's all. You don't have to worry about the rest. The way it works is very similar to, or at least the way the system is set up is quite similar to the previous cases. We have this neutral to ground contactor again, where actually we will. This is what I was talking about. This is to make the system standalone, okay? To make the system independent from the grid, okay? If the grid disappears, then you want to work as a standalone system So I'm talking about this gray box here. So then, if you want to do it that way, you need to actually install this neutral to ground contactor again. The non-critical loads can be also connected to this output, this signal, okay, this digital output. Here we also have the bypass contactor for maintenance operations in the inverter, and we also have the possibility to have additional or optional extra PV power installed in the system, okay? So as you can see, the system is quite simple. In this particular case, we will need to actually include this board, this Ingeteam SAN EMS board by default, okay? So you will be able to communicate at all times with the inverter if you use this approach. The second drawing shows a second approach to the same problem, okay? This is, let's say, the most simple way to do it. There's people who want to have this, instead of having this board, they prefer to have this other unit, the one we call Ingeteam SAN EMS Manager, and this basically is, it's loads depending on how much PV power you have. So if you have too much PV power, for example, you know that because you are communicating with your EMS manager, and so if you have too much PV power, then you could, for example, turn on your heater or turn on, I don't know, a water heater or something like that. Okay? This is a little bit more complicated, but well, at the end of the day, it's very similar to the previous case. This would be another approach to also do the same thing. In this case, with the EMS board again. Remember here we have the grid. The power from the grid goes into the inverter, and then it comes out from the inverter and it goes to the loads, right? And then you add the rest of the things at this, this side of your system. But sometimes, imagine that, in order to do that, you have to have the grid. The connection point to the grid. The inverter needs to be near the connection point from your grid, okay? Sometimes that's not the case, okay? Sometimes, for example, imagine that you have a residential system and you have the roof filled with PV modules. Then you decide to put the inverter next to the modules, near the roof. So obviously the connection point from the grid is far away. It might be in the basement, right? So it's not. Taking cables from one place to another is quite tricky, right? Taking cables from the roof to the basement might be a bit troublesome. So in order to avoid those problems, you could do it this way. Okay, you can install actually the inverter in the roof next to your PV modules. The only thing you have to do is to actually install an external power meter at the connection point from the grid, and take this communication cable, which is much thinner and less complicated to be taken from here all the way to the inverter. Okay. In this particular configuration, you will have the external power meter near the connection point from the grid. This will be in the roof. And you will also need to actually connect this to your loads, or you have to actually access your existing electrical diagram or the electrical system to actually plug there the power you're taking from, or you're producing from the inverter. What else we have? We have also non-critical loads, optional PV power. And this is for what I was talking about before, the standalone capability, okay, the standalone option. If you want the system to work as a standalone unit in case there's a blackout in the grid, okay? If there's a blackout here, then basically we realize of that because we are measuring here the AC power. So once this goes to zero, then you know that you have to start working as a voltage source. You have to produce voltage and frequency yourself. What you need to do is to actually disconnect with this contactor from the grid and activate this other contactor to put our neutral or the system neutral to ground, okay? And then you can actually work as a standalone system here without having the grid, okay? This is similar to the previous case. Instead of having this board here, we have installed this other unit, this EMS manager, that is able to actually control loads whenever there's a PV surplus. Okay, when there's too much PV production, then you can actually activate or deactivate loads using this element here. Okay. What else? There's another strategy. I'm not really going to enter much into this. I think I have pretty much covered, all the different things we can do with our inverters. So the next things I'm going to show are related to this topic, but I think it's going to be much easier to follow. Okay. But before I carry on, the other working mode, the last working mode is the one we call grid support. Grid support allows many things to be done. Basically, when we do grid support, what we are telling the inverter is to follow the indications given by this element here. Okay. In these previous strategies I was explaining, the inverter is the one in charge of managing the energy flows within the system. But if we implement this element here, we can actually tell the inverter, forget about thinking, okay? Don't make decisions. This element will be the one making the decisions, and you have to follow whatever specification or whatever this is telling you to do. So when you select that grid support option in the display, basically you're telling the inverter to follow the indications or to follow the rules or the whatever is required by this element here, the Ingeteam EMS manager. In this grid support, so basically what you have to do, is to go into this element and you have to configure it using a program that I will show you later on, the Ingeteam EMS tools. You program it to work in the way you want. Okay, for example, we have there implemented the peak saving strategy, which is meant to help us solar. In those cases, it's good to have such an element, such an energy management system to tell the inverter what to do at all times. Or systems with several external power meters. Imagine that you have several gensets, then you have several power meters for each one of the gensets. So all of that is wired to this element here, and this makes the decision about when to produce, how much to produce, which one needs to produce, things like that. And another strategy that is implemented with grid support is electric car charging stations. Okay, we have one of our products in the catalog is electric car charging stations, and they can be managed by this element as well. Installation. I'm going to show you now quite a few things to get an idea of how things are done, but I don't really want to spend too long in this because it's all in the manual, so if you take the manual, it's all there how to actually connect things to the inverter. This would be the inverter, okay? So this is where you make the conversion from DC power to AC power. Okay, here we will connect the batteries. Here we will connect the PV modules. And then we make the conversion. Here we have AC power. C stands for, this is for the transformer, which is optional. Then we actually connect or disconnect the DC side. And so this is how it looks from the bottom. But I have taken a couple of pictures that I took yesterday. I know that they are not very good, but I think they're good enough to explain, how this is actually wired. This is an inverter. I removed the cover, so this is how it looks from the inside. So actually, I'm gonna go to this bottom part where you can see actually where things are connected. Here are the batteries connected, the positive and the negative. These are the PV inputs, which are not connected in this particular inverter. Here we have, this is for temperature sensor for a PT100 that you can plug over there, you can connect there, and then that goes into the battery room, where the room where the batteries are kept. So you measure the temperature there, and you can actually know what's going on there at all times. What else we have? This is for the battery management system communication bus. Okay, this is where we plug. That lithium batteries have a communication bus because the batteries tell you at all times what's their state of charge. So in order to know that information, you have to plug that that cable to these 3 positions here. If you have any other type of battery, such as, I don't know, lead acid or nickel cadmium, the inverter makes the calculation of the state of charge itself. Okay, he makes the calculation of how much is the state of charge of the battery at all times. But in the case of the lithium batteries, then what we have to do is to take a cable into these positions here. What else we have? Well, Ethernet for communications, RS-485 for communications. This is where the display is connected. This is, well, actually the cover is where the display is located, and this cable here goes from here to the cover, to the display. So that's how you get the communication between the inverter and the display working. Here we have some free contact relays. This is to, well, if you want to activate several things, for example, if you want to activate the genset, or you need to send a command to the genset to turn it on, then you will need to make the connection here. It can be some other things, but, well, it's all included in the manual. So I recommend you go through the manual if you want to understand deeply how to make the connections and so on. Here we will connect our loads, the loads from the system. This is where we will connect the genset. And the last thing is the transformer. Okay, this is an inverter with a transformer, so we need to actually connect the transformer to the inverter itself. Okay, so this is how the connections are made. Okay, as you can see, it's quite simple. Basically, you have these cable clamps. You put the cable through the cable clamp. You make the connections. You clamp them using these elements here, and that's all. Okay, the system is now up. Is ready. Okay, you do all the wiring needed. You install the batteries. You install this. You install that. And once you have completed that process, you go through the display. You set everything up. You configure your elements. But that configuration can also be done remotely using this program. And here's where you can also configure some additional things. For example, all these peak saving things that I was talking about, or some other additional needs that you might have can be configured from this program. I'm gonna exit the presentation. Give me 1 second, because I'm gonna give me 1 second. I'm gonna share my screen. I'm gonna share my screen. So I'm going to access now one PV plant. Sorry, this is a single phase system, because only one of the phases is actually working. So this one is reading these values here and is telling these ones what to do at all times. Okay. Let me show you a few. Well, here you can play. You can add things, remove things, change the configuration. I want to include, for example, another inverter. All those things have to be done from here, okay? And then you can also monitor your system. I'm gonna click on data graphs, and I can show you. Let's see. I think this is what is happening right now, okay? So for some reason, this is being consumed from the grid. Okay, the batteries, for some reasons, I don't think this is. As I said before, this is a system that is being used by the people from R&D, and I can tell that these batteries, well, no, this is lithium batteries. That's why this state of charge is very low, but I think it's good. I mean, it's right. And we're at 9–10%. That's all right, because we have configured the batteries to drop down to that value. So they are discharged. So all the power now is being consumed by the loads, and we need some extra power that we take from the grid. Let's have a look to previous days. Let's see if we have something nice. For example, yesterday. You see, there's quite a lot of information here, but here you can see how, for example, this represents the state of charge of the batteries, how they discharge. Now they start charging a little bit more, and then at this moment in time, You start charging the batteries, they are represented with this orange color, and then you reach this much, and then because you don't have enough solar anymore, then you start discharging the batteries, so you provide all this power with this green color area with batteries and so on. Okay, have so many other. I mean, I think this you can see so many things here. So I'm gonna this is one day before. Let's have a look to, for example, on 1 week, what happened in the last week. Okay, this is the amount of power we have consumed directly from PV. Okay, the yellow color, this is how much we have actually consumed directly from the PV inverter. This is the green is how much we have consumed from the batteries. The blue is how much we have consumed from the grid. And the purple means how much power we have taken from the grid to charge the batteries. Okay, so as you can see, it's very good. We have reduced quite a lot the consumption or the energy bill for this particular system. Anyway, so I'm gonna go back to the presentation. I'm gonna oops, sorry. I'm gonna go back to the presentation, so I carry on with all the things that I have to explain to you. It's not gonna be much longer. Don't worry about it. I'm gonna finish in 2 or 3 minutes, and that will be it. Here I have an image. I have brought an image from the application that I was showing you before. This application will be available for mobile phones probably at the end of July. Well, I know these guys, they keep telling you, I know how things work here. They keep telling you, it's going to be there at the end of July, but normally it takes 1 extra month. So by the end of the summer, the tool will be available for mobile phone users, for Android and for what is it called? For Apple, for iPhone as well. Okay, I've seen the application already, but now they are working on, changing colors, to get a more visual or graphical, a nice graphical representation of things. So, I mean, the software has already been implemented. Now they are working only on the aesthetics of the tool. So hopefully by the end of the summer it will be available for sure. There's another program that I'm showing you here. Is not that important. Which is a program in the Console Manager that is free as the previous one, and it's meant to be used to monitor other inverters that you might have in your system. All those additional PV inverters we have connected to the system, they have to be monitored using this other program instead. Before I can, I'm gonna click on that link here. Hopefully it takes me to here. This is the page I'm talking about. And I'm gonna use worldwide because this is in Spanish, obviously. If I click on worldwide, this goes into English. Recorded courses, for example. Here you have several videos. One, for example, is with regards to Ingeteam EMS Manager, which is this thing I was talking about before. There's another one about Ingeteam EMS Tools, which is the program that I was talking about before. The access of these courses is, you have to just write down your name and your email, get into the course, and that will give you access to 4 or 5 videos. Each one of them lasts like 5 minutes or so. I mean, they are very short, and they try to explain to you, all the things we can do with these particular elements here. So I recommend you go through that, and because I think it's quite interesting. If you're thinking about using our inverters, it's better that you get to know exactly what you can do with it. Okay, I'm gonna go back to the PowerPoint. Yeah, there we go. So I have brought, to finish the presentation, a few references. The first one is for a system that we have here in Spain. It's a standalone system. Those are the characteristics that for that particular system. A nice picture. This is actually a brewery where they produce beer, and they're a bit far from the grid, and they don't want to. It's much more expensive to get them connected to the grid than to actually building up this system. So that's why they did it. The next one is a project we have in Namibia with PROINSO. That is a standalone system. Sorry, no, this is a backup system. This is the one that is meant to be, I mean, the batteries are meant to be for, they're meant to be used when there's grid blackouts. So it's very nice, actually. As you can see, the autonomy here is only 10 hours. You don't need any more than that. In this case, you need more, because if you have a cloudy day or a couple of or 3 cloudy days in a row, then your batteries might, get the. I mean, you need to have more autonomy just in case, Here we have this. I didn't have any pictures, so I brought a picture from Google. These are, we have 40 systems that were sold in Martin plants. They are pretty nice. They basically these were a company that were making properties, houses, and they were the house came with the batteries, the PV modules, and the inverter itself. Okay, everything was included within the house. So before you buy the house, you actually have all these things included, and they wanted to have, they wanted to have from I mean, they had this marketing approach that they wanted to be, green villas or the green village. So they wanted to have all these things included before clients could buy the property. So I think it's very nice. This is another system. For example, we have nearby here in Spain. This is a standalone system, but this guy has also the capability to have the system standalone in case he wants to. I mean, as I said before, here there's no many grid blackouts, but this guy decided to, just in case he might have something important in his property, or maybe he does things where he cannot allow any disconnection from the grid. So that's why he's got this self-consumption mode with optional standalone capability. Another one here for a system we have in Spain. This is a pig farm, or I don't know. I think it's either a pig farm or a rabbit farm. Here they have, this is a 3-phase system, with the transformers behind, and these are grid-connected inverters. These are Ingeteam Sunlight that are feeding power to each one of those phases themselves. So this feeds power into this phase, this feeds power into this other phase, and this feeds power into this other phase. Here you can see the battery bench with all the connection cabinet. So, well, this is a slide that the guys from marketing always tell me to include. That basically our approach to the business is to help our clients to, from the very beginning all the way to the completion of the project. So whatever you need, just let us know. And that's basically everything. But before I finish, I want to mention that I have also included this annex for sizing. Okay, I'm not gonna really enter into this because it might take too long. But I want to just leave it there. So if you guys want, you can go through it and see how these systems how they're sized. Okay, it's very simple. It's very straightforward. So I'll leave it there for you to do it yourself, and that will be it. Okay, so I'm pretty much completed. I don't know if you guys have questions or comments or whatever. So I think now is the best time for you to access the room and to ask your questions and go ahead.
If anyone has any questions, you just feel free to put up your hand. There's a little button next to the participant's name, and we can then unmute you and you can ask your question.
Well, if you don't have any well, yeah, I'm still waiting. But anyway, if you guys don't have questions now, but you have any question in the future, when you go through the presentation or whatsoever, just drop me an email. I'm gonna type my email address in here. Oops. Okay, that's my email address. You can also contact our colleagues from South Africa, from our South African office. They'll be happy to help you. And as I said before, if you have questions in the future, just do not hesitate to contact us because we're here for that. Okay.
Perfect.
Thanks
very much, Iton.
Thank you so much.
Thank you very much, Iton. Thanks to everyone for joining.
Thank you, Russell.
If anyone has any,
can you hear me now? Okay, great. I just wanted to check on the inverters themselves. Will there be an option in the future looking at being able to parallel inverters into each other in a single phase configuration?
Okay, that's a very good question. That's something we were analyzing in the past, and but at the end we decided not to allow that possibility. But I don't know what's going to happen in the future. I mean, so far, if you look at our catalog, in the past it was included the possibility to actually put several inverters in parallel in the same phase, but it's no longer there. But it's something that we still need to research and analyze in the future, and maybe next year we have news. But so far, we're not able to do it.
Okay, perfect. That's all I wanted to know.
Great. Thanks very much, Shane.
Thank you.
Is there anyone else with any questions? No, doesn't seem like it. Okay, well, in terms of the presentation, we will be distributing the presentation as Aitor talked about, as well as we have recorded this event. So we will be circulating the event going forward. And yeah, we'll do that with every single webinar training that we have. So you could build up your own comprehensive list of training, and you can give training to your own staff and you guys that obviously join and that sort of thing. Our next training will be happening next month. Feel free to join that training. We will send out invites very shortly to that training, and it'll be on BMZ lithium battery technology. And effectively what we could do is then, I'm sure a lot of people will be very interested in that training. You can ask any questions that you may have, and we'll have an expert on from Germany who will be talking about the BMZ battery and the integration to different inverters and that sort of thing. So if you're interested in lithium technology, please feel free to dial in. We will be sending out the invites. If you have any questions, you can also ask Jandre, or send an email to webinar@africansolarpower.co.za. Yeah, we take it from there. Thank you very much, everyone, for joining. We do appreciate it. And if you have any questions, give us a shout, and thank you very much. Have a good day.
Thank you very much.